All right, my friends, for problem 2, you'd want to start off by using the constant multiple rule for sums. So you'd want to factor that 1 over 121 out front. Sorry, that looks a little funny. So you'd be left with the sum as n goes from 1 to 11 of n cubed. And then from there, you'd have 100 and, oh my goodness, 1 over, I can't write that, 1 over 121 would get multiplied by, and now you could use the formula for the sum of all the cubes with an upper bound of 11. So you'd have 11 squared times 11 plus 1, or 12 squared over 4. And then from there, I was really hoping you would just cancel out the 11 squared with the 121. And so you'd be left with 12 squared over 4. And then if that was hard, I mean, you could always just kind of think of it as like 12 times 12 over 4 and then cancel, right? So you just left with 3 times 12. And so your answer would be 36. So, okay. Partial credit, we're going to give you 1 point for showing the factoring out of the 1 over 121. And then we're going to give you 3 points for doing the sum of all the cubes formula correctly. So this part in the circle, that's worth 3 points. And then the last point is for getting all the way down and evaluating it correctly and getting to 36. So there's your 5 points. Okay, let's see, problem 3 here. The first thing you would need to do is distribute sigma over subtraction. So this would equal the sum as n goes from 1 to 24 of n. Take away the sum as n goes from 1 to 24 of n squared. Okay. Then from there, it would just be a matter of using the formulas correctly. So the sum of all the integers from 1 to 24 would be your upper bound, 24, times your upper bound plus 1, or 25, and then all over 2, and then minus, and then now using the formula for the sum of all the squares with an upper bound of 24. So you'd have your upper bound times your upper bound plus 1 times double your upper bound plus 1 all over 6. All right, and then hopefully you canceled things down to make your life a little easier. So the numbers should work out really nice. So 12 times 25, you could think of 12 as 3 times 4. Because 4 times 25 is 100, so that makes that easy to do. And then over here, 4 times 25 is 100, and then times 49. So, okay, so this is 100, so you've got 3 of those, and this is 100, so you got 49 of those. And then it's just a matter of hopefully not screwing up subtraction. So your answer would be negative 4,600 for that one. Okay. Partial credit, 1 point for distributing sigma over subtraction, 2 points for using the sum formula for the sum of all the integers from 1 to 24 correctly, 2 points for using the sum formula for the sum of all the squares correctly, and then 1 point for getting negative 4,600 as your final answer. And that's your 5 points.